Okay. You can still talk your stories if you want. I'm not saying that. Yeah.
Like exactly.
People are too free. Huh?
We're too comfortable, honestly.
Wow. So, guys, let's go to revision exercise 3. Revision exercise 3. So if you can, you'll see that revision exercise 1 focuses on population. Revision exercise 2 focuses on the mean. Revision exercise 3 has 2 population questions and 2 mean questions. So if you practice just those 3, revision exercise 1, 2, and 3, woman dry. Revision exercise 1 focuses on population. Okay, so you'll be calculating SE based on population. You'll be calculating your Z-score based on population. Revision exercise 2 focuses on mean. So you're looking at the mean of the population and the mean of the sample. So you're calculating SE, you're calculating SE based on mean, and then obviously you'll be calculating your Z-score based off of the mean. Okay. Then revision exercise 3 has got both. So that's why I was saying if you practice 1, 2, and 3, just the revision exercises, forget those other exercises, you'll be fine for learning unit 7. Okay. Right. Okay. So now I want us to go back to question 3.1. Because remember yesterday I was saying, yay, I made a big mistake. Okay. So today we must rectify. So again, now I'm sure this image is now making a whole lot more sense, right? Okay. And when you go over unit 6, just a continuous distribution, it'll make even more sense. Okay. But anyway, let us proceed here. Experience has shown that the height of yes.
On that table, right?
Which one? This one? Yes. In this learning unit 7, they haven't given me I haven't seen an exercise where you do. But in learning unit 6, they do. And in those illustrations I'm talking about, they actually do that. Yeah, they actually do that. But remember, the question will simply say, what is the probability that the population falls between, let's just say, 10% and 12%? So they will give you an in-between. So that means we need to get the Z-score for 12% and the Z-score for 10%. Can you see? Yes, when you now get the probability of 12% and the probability of 10%, you will then look for the bigger one of the two and minus it from the smaller one to get the probability that you fall between those two. Makes sense? Okay. But yeah, do that learning unit 6 and then you'll be sharp. So here, experience has shown that the height of rose bushes produced by a nursery is normally distributed with an average height of 60 centimeters. So this is then obviously the height of the population, the average or the mean of the population, 60 centimeters. Okay, and a standard deviation of 9 centimeters. A sample of 105 of those rose bushes is randomly selected. So now we have our N, which is 105. Okay, so here they've got the order right. They've said determine the standard error for the sample. Okay, so they haven't yet asked us about any probabilities, but first they're saying determine the standard error. So here we're looking for the standard error according to mean, which is the SE is equals to the standard deviation divided by the square root of n. Can you see that? So yes, SE changes. That's what you're concerned about, isn't it? It changes depending on, are we working with population or are we working with mean? Yeah, here we're working with mean. So we've got our standard deviation, which we know is 9. And we know that our n is 105. So what is SE? What is our standard error? My friend who has just joined us. Sorry. No. I'm just telling you that we are doing revision exercise 3. Yes. Zero 0.8783. Okay, so now we have our standard error. We've answered question 3.1.1. Now we can go to 3.1.2. And what are they asking us there? They say, what is the probability? What is the probability that the mean, in other words, the average height of the rose bushes in the sample is greater than 59.50? Okay, I was just telling the guys yesterday that, today, that yesterday I made a mistake. So this is why I'm redoing it now with you guys. Okay, so let's do this in a different color. So again, to decipher, we need to say, what are we actually looking for? We're looking for the probability that X is greater than 59.50 centimeters. All right, that's what we're looking for. So then we say, we don't know the value of X, right? But again, we want to look at the equivalent z-score, because we know that this is normally distributed. So we can use the z-score to find the probability to solve our question. So we're basically saying, what is the probability that Z is greater than the equivalent z-score? And again, we don't know what the equivalent z-score is, so we need to solve for it. So this time we know to get your z-score, since we're dealing with mean, we're saying the mean of the sample. What is the mean of the sample? It is then this 59.50. Okay, we're using this 59.50. But we know, okay, let me, for the benefit of those who might be watching the video, let me actually put the formula here. So here we're saying X minus, sorry, this should be something like this, divided by SE, which is what we just calculated. So we then say 59.5 minus 60 divided by SE, which we just calculated to be 0.8783. What do we get as our z-score? Let me zoom out a little bit. Okay, and in your workbooks, I see they actually just rounded this off to 0.88. So we'll just round off the z-score so we are in alignment with the workbook. So just in the interest of time, your z-score is then going to be a negative 0.57. Yes, rounded off, but you're right. Okay. So now that we have the z-score, here you can see this is negative. Okay. And again, you guys only have the positive distribution, Z distribution table. So we then obviously need
you said in the test,
Yes.
there won't be a negative.
No, there won't be.
Our table will be positive.
No.
So
What I'm
the
saying
result
is,
will be positive.
what I'm saying is, in real life, there is a negative one. So you'd be able to look up this Z-score, just like this. But you guys are not going to be given a negative Z-score distribution table. So you only be given the positive one. So we need to practice our questions in accordance to that. Does that make sense? So that's all that I'm explaining. Makes sense? Put together? Okay, cool. It's good you asked, because yeah, I'm trying to prepare you. We're not only here to learn, we want you guys to pass. I don't want to see you next year, isn't? Well, actually, I do want to see you next year, but in the passages, hi, how are you? How are things? That type of story. Okay? She's laughing. Okay, so then we're basically saying we want the probability of 0, z greater than, less than 0.57, because isn't we said we are using the positive, and we said the distribution curve is symmetrical. Okay, now can you look up this for me? 0.57 on your distribution. Okay, so remember here we were looking for greater than. We know that when we look for greater than, we're looking for the space over here, isn't we? We've established this already. But again, because we used a negative z-score, we had a negative z-score, and then just assumed a positive one because of symmetry. Instead of, we know that when we have this type of situation, we say 0.5 minus whatever the positive z-score we would have obtained. But because we had a negative one, we have to add 0.5, which would then give us 0.7157. Okay. So yesterday, this is where I made the mistake. I took it a step further and said -1, which we weren't supposed to do. Yeah, so if you wrote yesterday's, you can just cancel out that last step. We were supposed to end here. Interpret. You must interpret the answer. I've been interpreting. So this, I'm going to give you this. I'm going to give you the fact that this is what? 71%, 71.57%. So guys, let's interpret now. Thank you very much, sir. I will go to the question. So we were looking at 3.1.2, and the question was, what is the probability that the mean height, in other words, the average height of the rose bushes in the sample is greater than 59.50 centimeters? What is the probability of that being the case? There's a 71.57% chance that it's easy. That's 100% it. You guys are saying exactly what your interpretation needs to be. Is it making sense? Okay. So question 2 and question 3, those are population questions. Okay. I want us to do question 4 because we already did 2 population questions. I want us to then do a second mean question. Okay, right. So let's look at this one here. Let's Can I? Okay, I want to move this. Okay, right. So let's look at this. Let's change colors. So question 3.4, it says, experience has shown that the number of hours of sleep per night required by teenagers is normally distributed. Guys, everything we're doing, we are only able to do it because we're assuming that the data or the information given to us is normally distributed. If they say it's not normally distributed, so you're going to have to find some other way of getting to your answers. All right, with an average number of hours, here they're actually giving it to you. In the exam, I don't think they'll give it to you. If they do, I don't know what you guys are then writing. Yeah, it's too easy, guys. You must be able to decipher. Okay? Hey, the death stay. Huh? I disagree. Unit 1, 4, what? It must be here.
No.
Yes. You need to practice to the point where you stop thinking. You're almost functioning on automatic.
You can't think and function. So whenever you want to think, you are not more time.
All right, so there we are. That's our mean for the population, isn't it? We go on. It says the standard deviation is 0.75 hours. Okay, so there's our standard deviation. We know that we're going to use this 0.75. And then it says a sample of 85 teenagers is randomly selected. So we know n is then obviously equals to 85. Now we have our information. All right.
So there's no sample for the percentage for the sample.
No.
X.
We
Are we calculating that?
that is here in this question here. You see. So we haven't yet gotten to that, but we will. So here it's slightly different from revision exercise 1. Revision exercise 1, they asked it within the information given. Here they've done the nice job of actually splitting it, because first thing they ask us to do is to calculate the standard error. Can you see? Which is the steps I was telling you guys. First you need to get your standard error, then you can go on to. So standard error, again, in this particular scenario, we know we're not using the P brackets 1 minus P, because that's for population. We're using the standard deviation divided by the square root of n. Okay, so let's get cracking. You see, you guys already know. You've already got it here. Can you see, my friend? So here, SE is equals to divided by the square root of n. So we're then saying standard deviation, we know it to be 0.75. And n we know is 85. So then what is this equals to? What is our SE? What is our standard error? 0.0813. It's all, oh, it's those weird, okay, no, it's fine. Let's just see where they rounded it off to here. Okay, yeah, so they left it actually here at 2 decimal place, so that's fine. So now we need to find Z. Okay, Z is then equals to X, in other words, the mean of the sample minus the mean of the population divided by SE. Okay, which is, okay, I can zoom in. So yeah, sorry, I didn't actually read the second part of the question before going into this. Let's read the question. What is the probability that the mean number of hours of sleep per night required by the teenagers in the sample is greater than 7.75 hours. So can you see that is then the mean of the sample, the 7.75. Okay, so we then say 7.75 minus the mean that we have for the population, which is 7.5, divided by your standard error, which is, okay, 0.08, according to your workbook, because they rounded it off. But yeah, you guys can take it further if you wanted to. Remember, they only say you must round off your answer if we're to think of this mathematically. You get 3 comma just, you know what, just give me all that you have and then we'll double check. 07 3075. Okay, fine. Yeah, we'll park it at that for now. Okay, let's see what we have here. So I'm getting 3.075. Oh, try calculate it with this. Yeah, try calculate it with that and see if you're still getting the same. 3.125 when you have included these.
When you said the 0.0813, it's the 3.07.
So remember that you said like we need to round off. So I put 0.08, not the 13.
Okay.
And then it gives me.
And then wait, let me see what you get when you just say 0.08, 125. Nah, it's too far off.
So we're not supposed to round. We're supposed to round off at the answer.
Yeah, you're supposed to, because even if we look at the answer, how they got there, they have 0.07. When I calculated, because I also have my calculators open to 6 decimal place, I get this. Let me show you. I get 3.073. So you see how the decimals obviously play a role, but at least we're within range, because if we round to 2 decimal place, we still have the same. Can you see that? So yeah, it means that don't round off. I say, yeah, work to 4 decimal place at least. Yeah, so that you're in line with. And when it comes to me, I'm gonna be checking to see, are you in line? Because some of you, you're going to be like me, 6 decimal place. Another one's going to be 5. Another one's going to be 3, or another one's going to be 4. So you're not going to get exactly the same answer. But if I'm seeing 3.07, then I'm like, okay, they're obviously on the same. They're following the same principle. Okay, so that's fine. Okay, right. So anyway, and the other part is, remember when we are looking for the Z score, we only need to 2 decimal place. So everything after the 7 doesn't matter, isn't? Did you guys catch what I meant there? We only work to 2 decimal place with the, when looking up the area or the probability on the Z-score distribution table. So you will all get the same Z-score. I mean probability. Makes sense? Okay. 3.08. No, don't round. Don't round. Because remember, the Z-score, we are still working with it to get to our probability. Yeah. Okay, right. So again, let's look back at the question. We now have our Z-score. It was saying the sample is greater than 7.75 hours. So we were looking for a probability. I'm going to use blue now. Probability that X, all right, was greater than 7.75. But again, we don't know what x is equals to. We know the data is normally distributed, so we want to look for the equivalent z-score, which we have done. So we're looking for the probability that z is greater than 3.07. Okay, right. And fortunately, can you see this is positive? So then we say, okay, what is the area or the probability that is equals to this 3.07 on our z distribution table? 0.49893. Okay? But again, remember we're looking for is greater than, isn't? So are we going to say plus or minus? Minus 0.5. And they say they're not having fun. I don't know.
It does not mean when you know how to do something we're enjoying it.
We are enjoying it. Hmm? So it's what? 0.1 what? What's our final answer?
Oh,
Or is it less than that?
yeah, it's 0.001.
0.001. Is it 1 or
107.
is it? Oh, okay, sorry.
0.00107.
Okay, right. So this is the same as saying 0 point times 100, 107, isn't it? And I think in your textbooks, let's see, I think they rounded it to 11%. Okay. So this then became, it's not even a full percentage. So again, when interpreting, what are we saying? We're ending here. Somebody give us the interpretation. And remember, there's someone on the other side of a YouTube channel somewhere that's listening to you. No pressure. No pressure. No, we don't know your name, Bella. We just hear a voice. Of your voice. You see, this is the problem. This is why as lecturers we run away from law students. You see this behavior. This behavior. Hmm? So, what?
So probability that the mean number of hours of sleep and night required by the teenagers in this sample is less than 7.75 hours.
Not less than, greater than.
Hours greater than, so what was the final number?
0.11%.
Oh, I thought it was 0.01.
So what are you saying? Sorry? Say what you're saying.
That I said greater than 7.75.
That's it. So the probability that the required sleep by the teenagers that were sampled is greater than 7.7 hours is 0.11%, which is exactly what you're saying. Okay. So guys, in your interpretation, don't be afraid to look at the question and then actually just almost copy it and then say this is the probability of that. You get what I'm saying? Okay. Yeah. So we can do another one. I was testing. So guys, we've done 2 population, we've done 2 mean. That's all they can ask in learning unit 7. From the questions that I've looked at. Yes. So as long as you understand the steps, you understand how each step seeps into the next, you're home and dry.
Whoa.
Yeah.